Hello, everyone. My name is Deepak Suri. I'm a product manager at AWS working on IoT. Along with me is my colleague, Scholl, who will join me on stage later. And together, we'll talk about what's new with IoT Analytics services. First of all, a huge thank you for all of you. I know it's the last session of the day, so thanks for coming. We'll try and get you all the information we have as quickly and efficiently as possible so that we can get you on your way. All right, so let's start with the IoT architecture very quickly. We try to address 3 questions with our IoT architecture. First of all, how do I build devices that can work with AWS and can also operate at the edge? The second question we try to address is how can I connect these devices to the cloud so that they can be controlled and managed at scale? And finally, the third question we address is around how do I extract value from my IoT data? We have a service category for each of these areas or each of these questions. So with device software, we address the how do I build devices that work with AWS, that question. Second, for connectivity and control, we have a category of services. It's self-explanatory. And then third is the analytics services. And we have a set of 4 services there. And that's where we'll focus today. So there is IoT SiteWise and IoT Analytics. Those are our 2 foundational services for extracting value out of data. And then we also have IoT Events, which is a service that helps build condition monitoring applications. And then Things Graph, which is a way to build IoT applications quickly and visually. So we'll walk through that further as we get into the session. But I want to start with just a session map for how to think about the content. First of all, why IoT Analytics services? What are the challenges that we're trying to address when it comes to analytics? Who needs these services? Who are the types of what's the type of persona that we engage with? And what capabilities are our customers telling us they need as they look at these services? So we'll set the stage with that over a few minutes, and then we'll jump to how do we address these requirements and capabilities through our services and what's new with them. So let's just start very quickly with the companies across industry verticals who want to, of course, operate their businesses much more efficiently, their organizations much more efficiently. And usually the questions that come up are, how do I reduce my costs? How do I reduce the raw materials that are used in, let's say, my factory? How do I get my devices operating better once they're delivered to my customers so that then I can improve the customer experience once these devices are on site or are connected from a home, let's say. Or use this information to then build the next generation of products in a much better way. Doing this at scale, our customers tell us, is hugely challenging. So you can look at a single machine and understand its efficiency, track its efficiency even on paper, but then as you scale this out and look at more and more machines or lines or factories or even an entire supply chain, the amount of data that needs to be analyzed and reviewed and then used to take actions on keeps growing. So that's the challenge that we then want to address. And not only, and as the scale of data increases, our customers also tell us that they want to look at patterns within the data and then enable automated insights or actions as well. The personas who we engage with in solving these problems are, first of all, line of business developers who need services that they can use to build their own applications. For example, if it is somebody, if it's a developer building a fleet tracking application within a logistics firm, or it's a process engineer or a developer building an application for a process engineer who needs an efficiency tracking application, that's the type of persona we serve amongst developers. And speaking of process engineers, they need visual tools, usually, to look at their equipment data and derive some insights from them. And then there are data analysts who would look at data in an aggregate form, maybe across even months or years, to understand patterns within their company's IoT data or equipment data, and then derive some insights that then translate to solving business challenges. So we talked about challenges, we talked about the type of people who work on these challenges, and then what's different about, or what's needed in terms of capabilities within these services. First of all, I think with IoT, folks recognize that the volume of data and the rate of data coming in is extremely high. There are customers who tell us that a fleet of turbines can be generating 1 billion data points every day that need to be analyzed and reviewed and taken action on. The data can be both hot or cold. So first of all, you can get hot data where you want to understand what's going on, and within seconds, or sometimes tens of seconds, sometimes within seconds, be able to take some action. Or it might be cold data where it goes to a cold storage, and you're looking at, again, if it's an analytics, if it's a data analyst looking at it, maybe they're okay putting the data in cold store and looking at it over a long period. The context of machines is important. So if you have, let's say, a fleet of turbines again, and depending on the manufacturer of the turbine and where it's located, the type of environmental setup, the type of maintenance history it has, the data is going to change. Like the meaning of the data is going to change. So that means attaching context of where the data is coming from is very important as part of an IoT analytics service. And as we collect more and more data, we are, of course, working with machines that also have been maybe built and installed and updated over many, many years, sometimes decades. And that means these machines are probably talking a range of different network protocols. The networks evolved with the machines, or both together, I guess. And that means we then have to have solutions for how can we enable the analytics services to then work with these different protocols, whether it's OPC UA in an industrial setting or MQTT with newer industrial applications. So there's an expectation to be able to work with these many protocols. And then going back a little bit to the machine context, sometimes you know what the data is going to mean. For example, if you can model, let's say, an equipment line or a factory because it's a static setup. So you can already set that up as a virtual model and then link the data to it. But sometimes you don't really know what you're looking for until you start getting the data. Let's say if you just launched a new product, you sold a number of them and they're installed in customer homes. And after you start to see what kind of usage patterns are being applied, then you can apply schema to the data and try to understand, get more insights. So having the ability to apply schemas or models before and after the fact are important. So it's not just data, it's also the metrics that you can compute on top. So you need, our customers tell us that they need, of course, the capability to do some simple mathematics or statistical calculations on top of data coming in. Could be averages or means, but could also be something like a Fourier analysis on, let's say, data coming from a vibration sensor that is important to an engineer. So a range of calculations may need to be done on the measurements coming in from equipment. And then you get into, okay, so you have data, you have calculated metrics, and then you need a way to observe the data. And usually this means having a visual way to observe the data, not looking at, it's not just log diving or looking at a lot of text, it's actually having something where you can look at charts or multiple visuals together to understand what's going on. And the reason you do this is, of course, you want to either root cause issues or just understand like how you can tweak your equipment parameters better. And of course, you can't look at the data all the time. So it's not a 24/7 requirement that you'd be sitting in front of a monitor to understand what's going on. You need alarms as well that would fire and help you understand when manual intervention is needed. And end with a list of capabilities where the edge is an important consideration as well. For many of the IoT applications, of course, there is also a requirement that, many times there's a requirement that the application works on the edge because there is a low latency requirement for the application to operate, or there is a compliance requirement where the data needs to stay on the on-premises, or simply the amount of data being generated, it's not feasible to send it over a network connection, in which case you want to process as much of it locally as possible before sending it over the wire to the cloud. So those are the questions that we think about and we want to address with our IoT analytics services. And over time, you'd see more and more capabilities that we add to address those questions. But what do we have today, and how do we address these requirements, and what's new is what we'll cover today. And we'll start with IoT SiteWise. For that, Saras will join me on stage to walk you through.
Thank you, Deepak, and thank you all for being here. As Deepak said, we really appreciate you being here for the last session of the day, especially when you have so many recreational possibilities out there. So we really appreciate your time. My name is Scholl, and I am the product manager for IoT Sidewise. We recently, as of Sunday night, announced a major update to the service. So I'm really excited to share those details with you today. Okay, so let's start with what are customers looking for in this space. To start off, a lot of our customers are now focusing on how do we make things smartly. For example, if we think about an automotive customer, what they're trying to do is build a connected factory or build a smart factory so they can digitize their production in order to drive higher efficiencies and to drive standardization for best practices across geographies. Another example is for a customer in the food and agriculture industry, and what they're trying to do is reduce wastage for their food processing sites, so they're able to reduce wastage and make sure that their processes are as efficient as possible. And the way they want to do this is by quickly identifying if there is equipment in their processing sites that is broken down or if it's operating inefficiently. They want to know these things quickly so then they can go remedy and rectify the situation and get back to an efficient production. So we'll focus in this part of the session on how does IoT SiteWise help these customers tackle these core challenges. Before I get into the nitty-gritty of the service, I want to give you a high-level overview of how this service actually works. So with SiteWise, there are 5 key steps. First, you want to start with collecting data at the edge from your factories and your equipment and uploading that to AWS Cloud. Then in the cloud, you want to create virtual representations of these factories and of these equipments. So the data that you're collecting at the edge and uploading is then attached to its corresponding virtual representation in the cloud. Next, you want to store that data in a managed, time-optimized data store. And then you want to start monitoring this equipment data or this asset data, and you want to do that quickly. And you want to do that in real time for both live data and for your historical data. And then finally, you want to be able to use this data that you've collected on the edge, and then in the cloud, you've attached all this machine context and equipment context to build your virtual assets. Now you want to use this data to be utilized in your custom applications, which you could have for various use cases. For example, if you're doing condition monitoring for your assets, you want to have this contextual IoT data being consumed as part of that custom applications. Or if you're doing predictive maintenance for your factories as well, you want to have that data flowing into your custom apps. Now let's get into some of the details here. We'll start with data ingestion. There are 3 ways for you to ingest data into IoT SiteWise. The first one that I'm going to talk about is a recent enhancement that we've included. We heard from our preview customers that they needed a way to ingest MQTT protocol data to IoT SiteWise. They told us that we already have devices connected to AWS IoT Core. We're already sending MQTT data, but I want to send this data to SiteWise to get more insights out of my device data. So we added support for MQTT protocol recently. Next, we have the existing capability of reading OPC-UA data and sending that to SiteWise. How that works is you deploy a software gateway as a connector on an edge device that is running IoT Greengrass. This gateway software polls your historian at the edge or your OPC-UA server at the edge and grabs all of those OPC-UA tags and uploads them to SiteWise. An enhancement that we introduced in this area is now you are able to connect up to 100 aggregators or OPC-UA servers to a single gateway and send thousands of data points per second to SiteWise. And then the third path of data ingestion is through the AWS SDK. We added support for sending data directly to SiteWise using the PUT API. What that means is you can have any application call our PUT API and send data directly to SiteWise, and this can include data if you have any proprietary or custom protocols that you're using, or if you want to connect data from your enterprise applications and have that sent to SiteWise. That is supported as well. Next, you want to create the virtual representation of your factories or your equipment. What that means is you want to create an asset, a virtual asset that mirrors how your physical asset actually behaves. And the way you do that is by defining properties. Now, properties in SiteWise can be of 4 types. In this example, I'm talking about a press machine, and we define an attribute property, which is more or less a static attribute for an asset. You can use that to define the make, model, location of an asset, stuff typically that doesn't change often. Next, you want to define a measurement property, which is the actual raw data coming in from your sensors or your equipment. In this case, the equipment, this press machine, is sending the widget output as a measurement, and we're storing that in the measurement property in the asset. Next, you want to, we have the transform property type, which is basically taking in these measurements and transforming them to look slightly different. For example, if you have a sensor sending in temperature data in Celsius, and you want to have all temperature data coming in to be stored as Fahrenheit as well, you can specify that as part of a transform property, and we will compute the Fahrenheit value for that Celsius value for each data point, and then store that back as time series as well. And then finally, you want to be able to compute more complex metrics on top of your device data or your equipment data, and you want to use a built-in library of operators and functions, and then have a formula that you define using a mix of your measurements and transforms to compute these more complex metrics. So those are the 4 property types that you can define that define the shape of your assets. Next, we recently added the capability to add model hierarchies. So that means you are now able to model complex relationships that exist in a factory and the assets and equipment within a factory. For example, let's say we have a model called a site. So say it's a factory. We model that using an asset model in SiteWise. Now, a factory itself or a site itself is made up of different assembly lines. Say one of those assembly lines is a metal press line. Now, we attach the metal press line as a child of the site model. Again, with the metal press line, you can have various metal presses, so the press machines, that actually make up that assembly line or that metal press line. So then we go ahead and attach the press machine as the child of a metal press line. So you can see in this way you are able to define more complex relationships between your equipment in a factory, and the ability to add hierarchy also allows you to roll up your metrics. So for example, you can be calculating the efficiency across a site using the metrics that are generated at an individual asset level or an individual machine level. Now, once you define your asset models help you drive standardization across your fleets. What that means is you define a generic model for an asset type, and any changes that you made to the asset, so for example, if you change the formula that you use to calculate a metric, that change is then propagated down to each of the instances of assets created from that model. So it helps with easy management when you have large-scale deployments. So once you have those models built, you have all your properties defined, you've defined hierarchies between your assets, you can now create individual instances of your assets. So for this example, we started with a site model. From the site model, I created an actual site, which is in Portland, so it's a Portland press shop. From the metal press line model, I created line 1, which is an asset, which is an assembly line, which is actually present in the Portland press shop. And within line 1, I created 2 assets, press A and press B, and those were instances of the press model that we created earlier. So you can see that this Portland press shop is now completely modeled, and it has inherited all its properties from the respective models, and it's inherited the hierarchies as well. Now that you have all of this modeled, your Portland press shop is ready to go. Now you want to actually start linking your measurements to this asset model. What that means is, from press A and press B, which is together making up line 1, you are sending your widget output measurement to an OPC-UA server in the Portland press shop. The OPC-UA server is connected to a SiteWise gateway, again, which is deployed on any edge device that's running IoT Greengrass. And it's polling the OPC-UA server for the widget output measurement and uploading that to SiteWise. You'll notice that the widget output for press A goes into the asset for press A. Similarly, for the widget output for press B, it goes into the asset for press B. So now you've linked your measurements from your actual physical equipment to their virtual representations in the cloud. Now you have all of this data coming into SiteWise, and you've attached all of this machine context to them. Now you want to store this data, and you want to store it in a scalable, time-optimized data store. SiteWise has a purpose-built time-series data store that we manage for you. That means there is no need for you to provision any capacity or plan for any storage capacity up front. We scale up and down as needed, depending on how your traffic is. And then we also compute common aggregates, such as statistical aggregates, such as average, min, max count, for a set predefined intervals for all data points coming in. And this operates on measurements. It also operates on transforms and your metrics. So you have pre-computed aggregates for all of your data, also stored as time series within SiteWise. Now, this allows the time series data store to be highly performant and provides low latency access to your data when you're trying to get data out of SiteWise. Talking about getting data out of SiteWise, there are 2 ways for you to be able to do that. The first one that I want to talk about is, this came up because a lot of our customers were telling us that we want to use this data that we have in SiteWise and all the machine context that we've attached to it, we want to use it in our custom apps in a streaming fashion. So for that, we introduced a publish-subscribe interface to SiteWise that streams data and any updates coming into a property to an MQTT topic. Now, you can be extremely prescriptive and granular about what data gets streamed out, and you can enable or disable notifications at an individual property level. Now, when you enable notifications for a property, every update coming into that property is streamed out and pushed into this MQTT topic, and then you can use AWS IoT Core to subscribe to that topic, get that data, and then route it to any of the other services in AWS or wherever you've built your custom applications, as long as you're able to subscribe to the MQTT topic. And then another way for you to be able to retrieve data out of SiteWise is to use our set of query APIs. So we have a set of query APIs that allows you to not only query for your latest value of the measurements, it allows you to also query for historical data for a time window that you define. And it lets you also query for aggregated values that we have stored for you on top of your measurements, your transforms, and metrics. And finally, we introduced IoT Sidewise Monitor as part of the Sunday's update as well. What is IoT Sidewise Monitor? Well, it is a managed web application that allows you to quickly get started and start visualizing all of this data that you have coming into SiteWise. You just log into the web application, and it supports your enterprise identity, and the users in your company, they don't need to have an AWS account. All they have to do is go to the URL for the web application and sign in with their corporate credentials, and they can quickly get started to start visualizing the data, their equipment data and asset data, and start driving insights from this. Now, once you log into the application, you can easily discover your assets. You can look at your asset library and visualize live and historical data and drill in and out from a time perspective to see more detailed data around your equipment and assets. And these dashboards can be quickly shared, quickly created and shared with users in your organization. This is a dashboard being created. You can drill in and out from just a drag motion, and then you can look at your asset library as well. And finally, I want to update you on our updated pricing that we recently announced as well. We had a lot of feedback from our customers, and to address that feedback, we wanted to simplify how we price for this service. So what that means is, instead of charging for data ingest in terms of how much data is coming in or how much data is being processed in terms of kilobytes or gigabytes, we now charge per message. A message is used to transport data in and out of the service. So now you can easily estimate your messaging charges by just looking at how many messages are being sent in and out of the service. Similarly, for data processing, instead of having customers to look through how much data is being processed as part of these computations, which could be challenging, we've simplified that to be a charge per number of computations that you have configured. For SiteWise Monitor, we have a charge per unique user per month. Storage charges remain unchanged. And currently, while in preview, there are no charges to use SiteWise. I want to give you a quick example of how one of our customers has been able to use SiteWise to solve some of their challenges. I want to talk about Bayer Crop Sciences. We worked very closely with them during the preview, and what they told us was that they were looking to reduce the wastage in their crop processing plants by being able to identify wasteful equipment and product quality issues. So they used IoT Sidewise to build an OEE, or an overall equipment efficiency application that was not only tracking the efficiency of the individual stages in food processing, but also at a site level. And using this application, they were able to monitor and report on their OEE across sites for 9 North American sites for this year's harvest season. So that was really exciting. Okay, so now, instead of doing a demo, I want to quickly show you how you can launch your own demo and see what value you can drive out of SiteWise. So what you're looking at over here is the landing page for the console for SiteWise. In the console, you can see on the right side, you have a Create Demo button. This is an easy button for you to click and get started. What it does is it builds a wind farm example for you, which has a set of 4 wind turbines as part of that wind farm. And we have some dummy data being pushed into these assets, so you can start really learning how SiteWise works, how do you think about metrics and transforms, and how can you quickly start visualizing this data. So let's go ahead and click Create Demo. Well, I already have a demo built, so let's go to that one then. Okay, so once your demo is done building, we can go into the View Assets section to see what this demo actually contains. So as I mentioned, this is a wind farm asset. The wind farm contains 4 wind turbines. What you're looking at right now is the asset detail page. It provides you all the details for this asset. Now remember, these details for an asset are coming in from the asset models created. So they are basically instances of the model. For this one, it's the turbine asset 4. So you can see that there are a number of attributes defined. If you scroll down, you can see the measurements that are coming in. For example, you have the wind speed and the torque coming in from the sensors, or in this case, dummy data, but in the real world, it would be sensors. And then you have transform defined, that is transforming these measurements into a different kind, or changing the units, for example. And then finally, you have metrics defined, that is basically calculating the average wind speed and the average power for each of these turbines. Now, if you go to the parent asset, in this case, the wind farm, you see that you can use the metrics defined in your child asset, so in this case, the wind turbine, to calculate the total power output for the wind farm. It just reads from its child's metrics and aggregates over a period of time that you specify, and it calculates this metric continuously. As you can see, we've attached the hierarchies down below here. So this particular wind farm has 4 assets that are its children, which is the turbine asset 1 through 4. And then now that we have all of this set up, our wind farm is functioning, we want to start visualizing what does this data really look like. So what we're going to do is we're going to jump to Monitor, and then view our portals. We've created a portal already. That's the URL for the portal. We'll go ahead and click on that. It's going to ask you to sign in. So again, this is a built-in user using AWS SSO. This is a quick way for you to get started and try out the monitor capability, or you can go in and attach your enterprise identity as well for authentication that you already have established in your companies. Okay, so going into the application, excuse me, we see that the plant manager has created a project, and he's called it Plant Manager, because it's his project. So let's go into that one. And we see that within that project, the plant manager wanted to start monitoring the aggregates. So he's created a dashboard to monitor just that. You go into the dashboard. Over here, you can see that the dashboard shows the average power of the farm. It shows the overdrive state time. It also shows the individual average power for each of the turbines. Now, the plant manager wants to go back in time, and he wants to visualize the data over the past day. So he can just pick the last day, and you can see now he has a lot more data to consume and a lot more data to analyze. If he wanted to go in and zoom in into a particular time period, he could just do a drag motion to see more details and drill into the data points coming in or being computed as the farm average power to see what are the variabilities, and basically be able to keep a close eye on how his wind farm is performing. Okay, so that brings us to the end of an overview of IoT SiteWise, and I hope you found all of the things that we recently launched and what's new with SiteWise really exciting. I would really urge you all to go create your own demo, see how quickly it is to get started, and see what you can achieve with IoT SiteWise. Thank you. I'll hand it over to Deepak to cover the rest of the services.
Thank you, Saras. As Saras mentioned, you can get started with a quick demo, and whatever we showed on the screen today, you can actually launch that with a single click, and you'll have enough data to look at with the portal. SiteWise is one of these foundational services that we have around analyzing data. IoT data. And the other one that we have that's we launched a couple of years ago is AWS IoT Analytics. With IoT Analytics, the focus is on more aggregate data, where schemas are applied after the fact. And here, the types of customers we see using IoT Analytics are usually ones who have large fleets of devices or connected products out there that they want to analyze data on. The working model with IoT Analytics is similar to SiteWise, I would say. There's still a focus on helping collect data. Once you collect the data, and you can collect data from different sources, they can come from IoT Core or through Kinesis, or you can use a put API using the AWS SDK as well. Once you collect the data, you ingest it, and it's processed. And the processing is done through a pipeline that is available through Lambda. So we provide a Lambda-based pipeline where you can attach some context to the data or do some transformations. You can even point to data and say IoT Core. If you have some shadow data, you can pull that in while the data is being processed. And the data then comes to a rest in Amazon S3. You put the data in, or we put the data for you in a time-optimized way in Amazon S3. And once it's there, we have built-in capabilities based on Athena and SageMaker to then analyze the data. We use Athena to help you run SQL queries in a scheduled way. And then also, you can also launch Jupyter notebooks to then get the data from generated through the SQL queries and then analyze them further or run your own application on top of the data. I'll actually cover what's new with IoT Analytics, and I'll start with the single-step process that we now have for setting up an IoT Analytics pipeline. Many developers, when they start off, they connect the devices to IoT Core, and then the first thing they want to see is, okay, like, am I getting data through? Am I seeing messages come through? And IoT Analytics is an easy way to start looking at that. So with a single click, you can now launch a pipeline that you can use with data coming in through IoT Core. And once you have data coming in, you also want to see whether there are messages coming through. So we have charts available within the AWS console. So if you're a developer and you want to look at data coming through, you can look at that. And then, of course, once data comes to rest, you want to start experimenting with queries to understand what is the content of the data and what is the content of the messages coming in, and what sort of insights you can derive. And usually that means running a few queries to understand the form of the data or shape of the data, and then get to your insights. So that you can do through the console today. And then when the data is at rest, one of the questions we got was, initially all the data in IoT Analytics was in an S3 bucket, but it was served as part of the service. We had an ask from customers to put this data in an S3 bucket that is owned by the customer themselves, so that they could integrate it with their data lake, or also, of course, meet compliance requirements where they needed to monitor usage of the S3 bucket that they put the data in, and finally also use the data with downstream applications in a more flexible way. So for that, we launched a customer-owned Amazon S3 bucket support. It's not just the raw data that you can store in your own bucket, it's also the data sets that you create as you run queries on top of data you import. Running the queries is possible through a scheduled mechanism with IoT Analytics. We used to support up to 5-minute granularity for scheduled queries, and we made a change to increase that frequency to support up to 1-minute granularity queries. This, of course, matters if you have a large volume of data coming in and you really want to run the analysis on a minute-by-minute basis instead of waiting 5 minutes. Now, how all this comes together is this pipeline that you see. I wish I had a pointer here, I don't, but if this pipeline can be set up automatically, the channel pipeline and data store all together can be set up through a single step. The data store that you see on the screen is something that is your own Amazon S3 bucket that you use. The data sets that you create as through setting up queries is also something that now you can create at up to a 1-minute granularity. So those are the updates that we have made to IoT Analytics. Along with SiteWise, which focuses on industrial data and helping customers make products smartly, and then IoT Analytics, where we help customers operate products smartly, we have a couple of other primitives that we believe are helpful to customers that we have built. IoT Events is one of them. The way to think about IoT Events is it's a condition, it helps you build condition monitoring applications, and it does this in a fully managed way. So you can set up a state machine in the cloud, IoT Events hosts that for you. It can process messages coming in from a device and then take actions on it in terms of setting up alerts or actions that can drive other AWS services or IoT events itself. So the flow then is you ingest messages into IoT events. They are then processed by models or detector models that you create. You just create a detector model, and then as you get more and more messages flowing in based on where the messages are coming in with, let's say, a device ID, instances of a detector model are created automatically for you. And each of these detector models is then going to process that information or process the message. And this is, of course, business logic that you would put in, and then take some action. So I'll walk you through a little bit on the console later on, but you'll be able to see that it's a simple detector model that then is able to process messages and then trigger some actions. Keeping with the flow from the IoT Analytics, what we added with IoT Events is support for Lambda as a target recently. So that means from within IoT Events, a detector model or an instance of a detector model can launch a Lambda function directly. There's also support for events itself as a target for IoT Events itself as a target for a detector model. The reason why this is important is it's usually not a single detector model. It's a bunch of different logic chained together. So if you want to do condition monitoring not at just a single sensor level, but based on aggregate information that you're getting from multiple sensors, then this is a way to do that, because you can chain together multiple detector models. You can send data out from IoT events to Kinesis Firehose and simple queuing service. So this is just this is just us being more and more flexible so that you can use events with more targets. And of course, it's expected that you'd be able to scale this out or deploy them easily. So there's CloudFormation support. And you can also export or import models across accounts. And then finally, we added more region support with events as well. So that's what's new with IoT events. Since the service is relatively new, I just want to walk through an example similar to what we did with SiteWise. So this is the IoT Events Console. And when you land there, you'll see that you can create a detector model. So when you create a detector model, you can actually launch one with just as a demonstration. So I'll do that now. What this will launch is a health monitoring application for a battery. So it will show a I think my credentials expired, so let me just do that. Okay, so I go back into IoT events. Okay, so when I create a detector model, I can launch a demonstration. And what this is going to do is create a hello world application for me. So what you're seeing here is a model of a battery where I can go from discharging to charging to charge state. And what you see here are the actions. So when do I transition states between, let's say, discharging and charging? And that is based on the voltage reading that's emitted by the battery. So it's not only can you set up this model in this way, but when you publish it, so I'm just going to publish this model, you can also go and test it to see what it looks like. So go in here, and since this is a demonstration, you can send sample messages into the detector instance and see what state it is in. So I'll send data. So you can see there's no instance created yet. So once I send some data, it'll create an instance for me. So what you saw there was I created a model, and once I sent the first message with some device ID, I got the first instance of a detector that was created for me. And it's in a charging state. Sorry if the font is a little small. Okay, so this should be better. So it's in charging state. I can then go back and send data for charged. So this is just a sample JSON message that gets sent. And you'll see that it then flipped to a charge state. So just a simple way to try out IoT events and think of ways you can use this as a primitive for a condition monitoring application. So with that, let me go back and conclude the session by talking about IoT Things Graph. Things Graph is a service that we built to help developers create IoT applications quickly and visually. Often, developers have to deal with lots of different device models or device types when building an application. So with Things Graph, you can actually create a model of a device that you're going to use and define upfront what the interfaces for the device are going to be, what is the logic within the device, and then use that within an application. You can also create a workflow, so you can connect many instances of these device models together to create a workflow. So a sample application that I like talking about is, let's say there is a badge reader that a person scans, and then based on that enters the room, and then a light bulb turns on. So what you could do with Things Graph is have a model for the badge reader, have a model for, let's say, the light bulb, and have a workflow that you built visually that executes in the cloud or on the edge that then takes the input, which is a badge was scanned, and there was an entry, and then based on that, send a command to the light bulb, the virtual light bulb, and that then turns it on. So that type of workflow is easy to create with Things Graph, because so that workflow is run for you. It's all based on models that are being pre-created either by you or by someone else in your company. And you can build these visually without actually starting without any code or low code, I would say. And the visual aspect is actually available through the AWS console. So you can, when you go into the Things Graph console, you'll have a way to look at the different models available. And these models map to both devices and even web services. And you can chain these together. And chaining these together is interesting, because then you can create multiple workflow forks. So badge is scanned, a light bulb is turned on. So that maybe that is one workflow, but maybe there is another workflow to raise the blinds, or another workflow to set the temperature in the room in a certain way. And all those workflows can be forked off of a single action. So you can create those visually in Things Graph and then start to edit them. So that we think is a power for developers in terms of helping build these IoT applications in a much more faster way. And I did mention edge upfront as one of the key capabilities that customers ask for with IoT Analytics services. With SiteWise, you saw edge data coming in through a gateway. With Things Graph, we have this whole application actually being able to run on the edge itself. So you can code up or use Things Graph as a workflow in the cloud, where all the orchestration and execution happens on AWS in a fully managed way. We do that for you. Or you can push these workflows down to run on a greengrass device as well, so that they run locally if there is a requirement around latency or compliance or data processing. So we talked about SiteWise Analytics. Those are our, again, foundational services for extracting value out of IoT data. We called out things that are new within these services. Events and Things Graph are our other primitives that help extract more value out of IoT data. So I'm going to leave you with these activities you can pursue to continue the learning around AWS IoT through AWS.training. And this was a fairly high-level overview of all that's possible with IoT Analytics services. We have a large set of sessions that you could attend or watch online that go deeper into each of these services and also tackle horizontal use cases. I do encourage you to look at these as well. With that, thank you. I do appreciate, and Saras and I thank you for staying for the last session of the day. And we're here to take questions.